everyone, welcome to another episode of LinkedIn Live Sessions powered by Volt Active Data. Most IoT systems today are very good at collecting data, but very few can actually act on the data in real time. And the gap between the data and the decision is where most business value is lost. Today, I'll show you how MQTT streams can directly drive real-time decisions, not dashboards, not pipelines, but actual decisions in milliseconds. My name is Biplab Banerjee and I work as the Director of Presales here at Volt Active Data. Over the next few minutes, I'll walk you through the different challenges in the IoT data streaming, how differently Volt approaches it, and followed by a quick live demonstration. Let's start with the reality of IoT systems today. We are dealing with high velocity sensor data, high volume telemetry data, increasing complexity of the systems that are involved in processing these data. But the real challenge is not about ingesting. It's about taking decisions in real time. Because in most architecture, data is collected, moved through different pipelines somewhere else, processed somewhere else, and finally analyzed. By the time you act or take the decision, it's already too late. This leads to delayed insights, missed anomalies with limited automation. So most systems today are really great in storing and moving data, but there are very few who can actually decide right at the moment when the data is getting ingested. So what if we flip this model? Instead of stitching different technologies for data movement, processing events and streams, databases, APIs, what if we could have one single solution that would be able to cater to all of this, still be scalable enough, and still provide the low latency, immediate decision making? That's exactly where Volt Active Data comes, and this was designed for. There are three key ideas here. The first is unified platform. So streaming, processing, analytics, all in a single unified data engine. The second is real-time event processing. So as soon as the data is ingested from the MQTT brokers, you can filter, transform, correlate, enrich, and apply your business logic as you want. And the third is instant decision making. So you get a flexibility of writing your own business logics and trigger actions at the back of those business logics, right from standard plain SQL to going more complex with further complex languages that are supported like Java, Python, etc. Let me simplify the architecture in one idea. Every event follows a single life cycle: ingest, process, decide, act, store. An MQTT event is produced from the source. On the extreme left hand side, it could be edges device, it could be sensors, it could be industrial systems. These events are then sent to an MQTT broker. From MQTT broker, these events are then forwarded to Volt, where we ingest the data immediately, apply the business logic, and take the decision immediately. These decisions can then be pushed back to the MQTT broker, and further your actions or equipments could be controlled. And then the processed data could also be sent downstream to the data warehouses or long-term data storage purposes that you would see on the extreme right-hand side. So, and this is just not a pipeline. This is a decision engine of how Volt Active Data acts here. So let's move to a demo and see how Volt Active Data makes this possible. I'm going to simulate some sensor data using our partner solutions from EMQ Technologies. EMQ Technologies provide different kind of tooling and solutions for IoT systems. I would be using their MQTT X event producer client and push that data to a public MQTT broker by EMQX. And from there, Volt will consume the data and process the data based on some rules that I would configure in Volt. and be able to show you some decisions that could be taken, and also will show some real-time analytics queries which we can run directly on Volt, and we'll get some insights. Let's dive in. So as I said, so we have this MQTT client. This is contributed as open source by one of our partners called EMQ Technologies Incorporation. Using this client, we'll push some events to a public MQTT broker. The public MQTT broker is again provided by EMQ Technologies. What I have done is I've created a topic there, and I am trying to connect to that topic basically and push some events. So if you see here, I am pushing some messages with error or OK with some device IP and a device name. What happens is this information will be sent from the client to a public MQTT broker topic, and Volt will consume from this topic. So we have Volt here. Volt is up and running. We have two tables, alerts and greetings. So if you see, basically what we have here is a table called greetings, which is like a base table where all the events will land and get stored. And then we have an alerts table where in case we get an alert, we log the alert in this table. Between these two tables is the decision logic, which is your business logic. So as the events are coming in, the events invoke this procedure, and in this procedure, we insert it into the base table first, and then also we insert it into alert stream in case it fulfills my logic, which is in case I find a message with error, I would log it in the alerts table. If not, then it does not get logged. All of this happens atomically in one single transaction. So let's look at how this happens. So right now, if you see my screen, I just have some two records in the greetings table, and in alerts table I just have one record. Let's just push some records from the client. I'll change the IP in the client and I'll change the message. So what I'll do is I'll send some OK message from let's say 128 and the last digit is, let's say, 20, right? With the device name as 2, right? And I'll use this device to send this event. What happens is this event is now sent to a public MQTT broker, and Volt consumes from the public MQTT broker. So we'll go back to Volt and see. And now we can see a record is inserted in the greetings table, and the count has been increased by 1. In the alerts table is still 1 because the message was OK, obviously, and it did not get logged. Now let's query the table and see. So I'll query the greetings table and show you. So we have 3 informations. Here is the device 2 event with OK message, and the alerts table should not have this message because it was OK. So we do not have any event from device 2. Now let's just push another event for the same device with message as error, right? And let's just push this event. This event is pushed. Let's go back to Volt. So we see now the alert count has been increased by 1, which was previously only 1, and now it's 2. Greetings, of course, now that we have sent one more message, is now increased by 1, which is 4. So let's query the tables. So let's run the greetings table. Now we have a new message in this table with error as the message, and then let's look at alerts table. We now have a event recorded from device 2 with message as error. So this is how a logic is basically helping you take decisions. In my case, the decision is to log an alert in the alerts table. We can map these, instead of logging it in alerts tables, we can map these to a stream table and push the events back to some downstream consuming systems, which would then further control an operation, or would just need these events for alerting purposes or anomaly detection purposes, right? Now that was about operationally how fast we could ingest and how easily we could ingest, take a decision all while storing the data. What I'll do is also I'll simulate some 100 events per second being sent through the public MQTT broker using a backend client, MQTT client, and we will ingest that data at a very at that rate inside Volt and see how the data is getting ingested in the greetings table as the base, and all of them which would comply to my business rule or logic to take the decision would be logged in the alerts table. So I'll go to my backend and I'll run. So what I've done is I've created a let's say a load generator. I'm running about 100 TPS for now, trying to send 100 events per second, which will randomly send some error-based messages and some OK messages, and for about a minute. And let's see what happens. Okay. So my event generation has started already, and let's just go at Volt and see what's happening here. So if you see, I have started receiving some throughput here, and my TPS is slowly getting up to 100, and yeah, we can see it here. So let's say now it is at the rate of 94, 92, and my latency is about fairly below less than 10 milliseconds, and my counts on the greetings table and the alerts table is significantly started increasing and started logging those events as per the decision logic. And we can see my message sent, my client has ended, and I have about tried to achieve about 97 TPS in my case, and all of those events are now logged in Volt, and the workload in Volt has also ended, and we were all fairly less below 10 milliseconds. Now that we have ingested certain records in alerts and greetings, let's look at the third third element or property of Volt, which is being able to have real-time analytics. So you can run some quick real-time analytics on Volt directly on the data that is being stored while the data is getting ingested, or even when the data is still available there for storage, right? So let's say what happened in the last 100 seconds. So I could see that in the last 100 seconds, I got 686 events that were recorded. Now let's see the distribution of events per IP while querying the greetings table. What I'll do is I'll run this query, and I could see the distribution of the count of messages received per IP. Now let's say we need to look at the distribution of alerts by devices. So we have this query. We can run this query and look how the alerts are there available that we have ingested by devices. So we could see that we have typically about 1 messages per device in this whole system for now that was generated by the benchmark. So let's go back. So what are the key takeaways from today's session? What we saw is a unified architecture for real-time decisions. We were able to ingest this data, process that data, take some decisions, store that data, and also perform some real-time analytics, all using through a single platform with no glue code. We were able to take decisions in milliseconds. So we were applying business logic when the data was arriving on top of it, also while storing it and taking the decisions and sending it back for action. And we also see how simplicity works with Volt because we were using standard SQL to build the logic, ingest that data, store that data, and query that data for analytical purposes. But then this is also built for production grade because we are able to offer scalability as well as maintain the quality of service for IoT systems that is needed, whether it is in terms of message delivery. So what we are trying to state here is that this is not just a pipeline, this is a full decision engine. If you want to try out Volt, you can type in www.voltactivedata.com/buildwithvolt. You land up on the page of Volt Active Data. You get to explore this demo that you saw today, or you could try the Volt by yourself by clicking on Try Volt. Please do like, share, comment, and follow our LinkedIn page and YouTube pages.